All right, we're on our second lesson for the building blocks of geometry. We are going to look at angles and triangles then. So first off, we're going to classify what some angles are. A right angle, a lot of this should be review. Our right angle is one that is exactly 90 degrees. You'll notice you have two lines here, or two rays technically in this sense, two rays that intersect at a 90 degree. That has a little box there. That means 90-degree angle there. They are perpendicular to each other. They make a right angle. An acute angle is any angle whose measure is less than 90 degrees. Now, none of these are actually written on there exactly what they are, but just kind of judging by looks, which you shouldn't necessarily do, but judging by looks on this, we can see that it is less than 90 degrees. So these would all be acute angles. Anytime it's less than 90, that's acute. This one is really, really small, maybe like 7 degrees. This one is, maybe in the 20s, almost 30 degrees or so. This one is really close, maybe like 89 degrees. It is not quite 90 though. So these are all acute. Obtuse angles are angles that are more than 90 degrees but less than 180. We have to include the fact that they are less than 180 because if they were any more than 180, it would look something like this. Here is one part of it. Here it is acute. Here it is, right, because it is 90. Here is obtuse. If I keep going past 180, now look at that, it's way too big. It's so big, going from here all the way around, that it's actually accidentally over here made an acute angle. So even though this one is way big, this is actually an acute angle. So it's kind of a weird way to look at it. We always kind of judge our angles based on anything less than the 180. So obtuse is when they're more than 90, but still less than 180. The last one we're going to look at is a straight angle. Kind of that term, that word there, straight, just means it's exactly 180 degrees. It makes a straight line. If you, again, if you're walking in one direction, you turn 180 degrees, you're going the exact opposite direction. You've made a straight line, just going in one direction, then going in the other. So that's kind of our, based on all these measurements, that's what each of our angles mean. Our angle relationships. Adjacent is one of them that we can look at. And again, some of these should be review. The word adjacent just means next to. So if you think of your adjacent neighbor, it's only the neighbors whose yard touches yours, not people who are somewhere across the street or across town. It's only next to you. So for angles, this means angles that share a vertex. They all have the same starting point there, and they also share a ray. So in this example, it looks like angle PQR, I'm going to draw it as this red one, we would say is adjacent to angle RQS. Notice I've drawn them a red one and a green one. These two are called adjacent because they share this ray, QR. They have that same piece there. They have the same vertex at Q, so they are adjacent angles. They are right next to each other. They share that line. I'm just going to get that. Angle PQR is adjacent to angle RQS. Now, this symbol looks like a less than symbol when I type it out on this software. I want you to draw in, should look something more like this. Remember, that's our angle sign. Angle PQR is adjacent to angle RQS. Complementary. Complementary angles are angles that will add up to exactly 90 degrees. So these two complementary angles do not touch. They are not adjacent, but 27 degrees plus 63 degrees does add up to 90 degrees. So these would be considered complementary. Now on these ones, if you look at it, you can see this larger angle is a right angle, has the little box there, so it adds to 90. 40 degrees plus 50 degrees, they add up to make 90, so they are also complementary. As well as being complementary, they're also adjacent. We have, whoops, kind of got off there. There's one angle, it's 40 degrees. Here is one angle, it's 50 degrees. These are adjacent and complementary angles. Right next to each other, share this ray, share this vertex, and they add up to 90 degrees. Supplementary. It's very similar to complementary. It means they add up to 180 degrees. So again, here's a pair that aren't touching. They are not adjacent to each other, but 60 degrees plus 180 degrees does add up to 180. Sorry, did I say 180? 60 plus 120 adds up to 180. So these would be supplementary even though they don't touch. These ones are supplementary and they do touch. So again, we've got a 40 degree angle here. We've got a 140 degree angle over here. So these are supplementary, add to 180, and they're adjacent. They share this side and this vertex. Linear pair. A linear pair are two angles that share a ray and a vertex, meaning, okay, so these ones are in fact adjacent. So here is the ray shared by these two. Here is the vertex shared by these two. And each of their second rays is on the same line. This ray, so here we've made this big angle, this green angle, and this ray, here we've made the red angle with that blue ray, the one they share. This ray and this ray are the same line. Okay? These would then be called a linear pair. Two adjacent angles that form a line. It's another way to think of it. Basically, if you have a straight line, this line MN or MO or NO or OM, whatever you want to call this line here, if it has an extra ray coming off of it, it makes a linear pair. These two are the linear pair. Now, somebody had to go through and prove this using everything they know about everything, putting everything together. The theorem that they proved is that if two angles form a linear pair, then they are supplementary. Now, that should make sense because normally a straight line like this is 180 degrees. So, this green one and this red one should add up to 180 degrees, which means they should be supplementary. Remember, supplementary add up to 180. So if they are a linear pair, they add up to 180. They are supplementary. It seems, again, it seems like common sense, but it's just a theorem that we have to write in there. Vertical angles. Now, anytime that we have two crisscrossing lines like this, it kind of makes an X. You've made some vertical angles. These are the opposite angles made by intersecting lines. So, for example, 1 and 3 are vertical angles. This one is vertical with this, which makes sense because vertical is up and down, but also 2 and 4. That one is a little bit more goofy because they actually look horizontal, right? They look like they're going sideways. This term, vertical, you can almost kind of put quotations around it. It doesn't mean vertical as though up and down. Vertical angles are just across from each other when you have crisscrossing lines. 1 is vertical to 3, 2 is vertical to 4. There is a vertical angle theorem. Now what that says is, let's say this one I'm going to do the 2 swoops for. Angle 3 has to be congruent to angle 1 because they are vertical. Similarly, angle 2, and I'm going to put 1 tick mark there, is congruent to angle 4 because they are vertical. Okay, the vertical angle theorem just says vertical angles are congruent to each other. So if I were to come by and say, I measured this and this is exactly 120 degrees, well then you would know, oh, this one is also 120 degrees. It has to be because vertical angles are congruent to each other. Okay, so again, might be something you knew from before, but just something we have to go over. These are called vertical. Because of our theorem, we know that they are going to be congruent. Let's classify some triangles. I want you to draw these examples in your notes. Even if the pictures aren't there, you don't have to draw every single one, just an example. A scalene triangle means that there are no congruent sides or angles. none of the angles and none of the sides in any of these triangles are the exact same. Now notice in this example, I like it because it uses the tick marks. You can see 1 tick, 2 ticks, 3 ticks, meaning that none of these are the same as this one, none of them are the same as this one, none of them are the same as this one. So it's 3 different measured sides. So if none of the sides are the same, it is a scalene triangle. That is opposed to an isosceles triangle. Isosceles triangle has exactly 2 congruent sides and angles. Now the angle part isn't drawn on here, but you can draw it on if you want. This side is congruent to this side. The double tick marks mean they're the same. Now, we haven't gone over this theorem yet, but I will let you know that across from this angle, or across from this side, this angle right here is going to be the same as this angle here. The sides that are across from each other go from this side to this angle, this side to this angle. These angles have to be the same. And again, that should kind of make sense. Maybe on, let's use a smaller one like this. You can see that this one is way little. This one is also way little. These are the 2 angles that are the same because they have 2 sides that are the same. This one is the same as this. This one goes with this. Okay, so we have scalene triangle, no congruent sides, isosceles triangle, just exactly 2 congruent sides, not all 3. Equilateral means that all 3 sides are the same. Now, this also goes along with saying equiangular. There are 2 kind of pieces of each word. Equi means the same or equal. In this case, we have the word lateral. Lateral just means the side length. Same side lengths. Angular means angles. Same angles. Any triangle that is equilateral is also equiangular. Any triangle that's equiangular is also equilateral. So these kind of mean the same thing. According to the pictures, these describe more of equiangular. They all have the same angles. Now we could put the tick marks in to say this side has to be the same as this side, has to be the same as this side. That is an equilateral triangle, all the sides the same length. 60 degrees, 60 degrees, 60 degrees, equiangular. They all equal the same angle. So it's any triangle that has exactly 3 congruent sides and all of the angles are exactly 60 degrees. So even though these don't have an angle measurement, if they're all the same, they're all going to be 60 degrees. The last kind that we're going to look at is a right triangle. Somewhere in that triangle there's exactly 1 right angle. So in this one you can see here's a right angle. So this is a right triangle. Here is a triangle with a right angle. This is a right triangle. So anytime that you have a triangle with exactly 1 right angle, it's called a right triangle. Now we have what's called the Pythagorean theorem. I want you to write down that this only works for right triangles. And what it means, so it only works for those right triangles, is that if we have a right triangle like this, we have sides A, B, and C. Notice that C has to be across from that right angle. So A and B can really be either one, but C has to be across from this. You might want to make note of that. Then you can say A squared plus B squared equals C squared. The length of A squared plus the length of B squared is going to equal the length of C squared. Now it is called a theorem because somebody, actually many people, have had to go through and prove that that works for any right triangle. They had to go through, list a lot of different steps to prove or to show beyond a shadow of a doubt that that will always work. We're going to look at some examples in our next video then.